Lesson 44, Regression Analysis. Example 1. Can the height of a person as an adult be accurately predicted based on their height at age 2? In order to address this question statistically, a sample of 22-year-olds who had their height in inches measured within 2 weeks of their second birthday documented in medical records had their present height in inches measured and recorded. The results are presented in the table below. Note that these heights were rounded to the nearest quarter of an inch. Conduct a linear regression analysis using this data in order to predict the height of a person as an adult based on their height at age 2. And, if it is appropriate to do so, use the linear regression model to predict the height of a person as an adult, given that they measured 36¼ inches tall on their second birthday. So first we need to conduct a linear regression analysis. The linear regression model that will best predict y based on x is given by the formula y hat equals to a times x plus b, where a is the slope and b is the y-intercept. This linear regression analysis will be used to predict the height of a person as an adult. The predictor variable is the y variable. So in this case, we know that we're going to predict y equals the height of a person as an adult. This prediction is based on their height at age 2. And the variable that is used to base the prediction on, called the predictor, is the x variable. So in this case, we're going to base the prediction on x equal to their height at age 2. Now, if it is appropriate to do so, we will use the linear regression model to make our prediction. It is appropriate to use the linear regression model to make predictions when the coefficient of determination r squared is close to 1. Now, referring to our guide for conducting a linear regression analysis, we see that in order to use the TI-84 calculator to calculate the results of the regression analysis, we first need to enter the predictor, or x data, into list 1, and then we need to enter the predicted, or y data, into list 2. So since we are predicting the person's height as an adult, the predicted, or y variable, is the height as an adult. And we're basing this prediction on their height at age 2. So the predictor, or x variable, will be the height at age 2. So we'll enter in the person's height at age 2 in list 1, and then we'll enter in the person's height as an adult in list 2. This could be done on the TI-84 calculator by pressing Stat, Enter, to get to the list editor. Then we arrow up to the list name and press Clear, Enter, to clear out old list to make room for the new data. So in list 1, we'll enter the height at age 2, starting with 33.0, enter. 35.75, enter. 31.5, enter. 34.0, enter. 29.75, enter. 37.0, enter. 32.5, enter. 36.25, enter. Then we arrow over to list 2, where we enter the predicted, or y variables, starting with 64.5, enter. 69.25, enter. 63.25, enter. 68.0, enter. 57.5, enter. 72.25, enter. 67.5, enter. And finally, 74.0, enter. Now that we've entered our x variable into list 1 and the y variable into list 2, we can then continue with our linear regression analysis and execute the lin reg ax plus b list1, list2 command on the TI-84 calculator. We find the linear regression command on the calculator by pressing Stat, arrow over to Calc for calculate, and then arrow down until the cursor is next to the linear regression AX plus B command. We press Enter to select, and then second 1 to bring up list 1, comma, second 2 to bring up list 2. Enter. Calculates our linear regression results. So the linear regression model that will best predict y based on x is given by y hat equal to 1.975 times x plus 0.437. Here, the slope a is 1.975 and b, the y-intercept, is 0.437. Now, in order to determine if it's appropriate to use this regression model to make a prediction, we need to know the value of r squared, the coefficient of determination. Here we see that the r squared rounds off to 0.888. So interpreting our linear regression model, we see that if we take x, the height of an individual at age 2, and multiply it by 1.975, which is essentially doubling it, and adding a little 0.437, we'll end up with y, the predicted height as an adult. So it appears as if the height of a person as an adult is roughly about 2 times their height at age 2. And if we want to interpret r squared, the coefficient of determination, we see that about 88.8% of the variation in the person's height as an adult can be explained by their height at age 2, thus leaving only about 11 or 12% of the variation in the height as an adult determined by some other factor. So using this results, we can make the following statements. The linear regression model that will best predict the height of a person as an adult in inches based on their height at age 2 in inches is y hat equals to 1.975 times x plus 0.437. And since the coefficient of determination, r squared equals 0.888, is pretty close to 1, the linear regression model fits the sample data pretty well. Hence, it would be appropriate to use this model to make a prediction. So, since it was deemed appropriate to do so, we will use the linear regression model to predict the height of a person as an adult, given that they measured 36¼ inches tall on their second birthday. Here, the 36¼ inches is their x value, height at age 2. Plugging this x value of 36¼ or 36.25 into the linear regression model, we get y hat equals to 1.975 times 36.25 plus 0.437, which roughly equals 72.03. So, thus, the height of a person as an adult, given that they measured 36¼ inches tall on their second birthday, is predicted to be about 72 inches, or 6 feet tall.